Alexa.
Colton. Riley.
Okay, so we had section 2, question 1 and 2. And question 1 says differentiate between a mutation and a substitution. And so a substitution is actually a type of mutation, but a substitution won't always be a mutation. Substitutions are where one base is substituted for the other, and so you could have AGT, but it's substituted for like AGC. But a mutation will completely change the way the bases are read for the amino acid sequence, and substitutions won't always change that sequence of amino acid.
Number 2.
Okay, so which are more common, silent or replacement substitutions, and why? So I'm going to explain a little bit about what silent replacement substitutions actually are. So a silent mutation, there's something called the wobble effect. So you know that a codon is going to have 3 different bases, and the codon that the bases actually code for are actually going to be based off of, generally the first 2 are the most important, but that third is what we call the wobble effect. On that third base, it can actually cause, there's actually a lot of different bases that can code for the same one. So due to the wobble effect, there can be mutations on this third one that cause what we call a neutral or a silent mutation, where it won't change the amino acid sequence, it won't actually change the chain. So because it does that, it won't actually have an effect phenotypically, you won't see a change. So on the replacement substitutions, it's when there's usually a change in one of those first 2 bases, and when it changes that, it'll change the amino acid, it'll change how it works, or it might turn it off, or make it better, or make it do something else. And because of that, there's an actual physical phenotypical change.
Yeah, and because there's a phenotypical change with replacement substitutions versus silent substitutions don't have any change. That's why we see more silent substitutions than we do the replacement, because silents don't have a change, so they can stay in a population and have no effect, but they're in high frequency in a population because they don't have natural selection working on them like a deleterious, I think is the word. Is that deleterious?
Yeah, deleterious.
I don't know how to pronounce it, but when a mutation causes a disadvantage, selection can work against that, and so that mutation usually leaves, and that's where a replacement substitution could cause that. And if the replacement substitution caused a positive effect, oftentimes, as the book said, it will be masked by migration or gene flow in that population, or it'll fixate. And so the silent mutations can occur more often and can stay in a population without having mechanisms of evolution affecting them, so they're more common.
That's right.
Oh, it's still going.
Oh, man.